Analytical investigation of a deterministic inventory model using the cubic demand rate and the exponential distribution as deterioration rate. Abstract. This research looks into an inventory model for decomposing items or products with a cubic demand over time, with an exponential deterioration rate. In the model, shortages are allowed. It also shows that the cubic demand function is convex and yields the best result. A three-dimensional graphical representation of this model's convexity is shown. An illustration is created to double-check the model. The ideal solution was put through a sensitivity analysis with respect to the main parameters, and the results were presented. Keywords: deterioration, cubic demand, shortages, total inventory cost. Introduction. Inventory is defined as the stock of items kept on hand to ensure a trade or business's efficient and smooth operation. It also contributes to the company's growth. Manufacturers, schools, farms, hospitals, and higher education institutions all rely on it. Both merchants and wholesalers must keep their inventory of things or products at a minimum. It is made up of several diverging conditions that can be turned into models. These circumstances could include deterministic demand, demand changes over time, degradation, and so forth. The mathematical model is distributed into two kinds, i.e., deterministic and stochastic models. Deterministic and stochastic mathematical models are the two types of models available. The demand rate is constant in the deterministic model. In inventory, demand is quite crucial. The demand rate was expected to remain constant in the basic inventory model. However, this isn't always possible. For many inventory products, like fashionable items, dairy goods, electric items, fruits and vegetables, and so on, the hypothesis of not changing demand rate is not appropriate. The demand rate may be dependent on time, stock, and on price. Fruits, vegetables, medications, dairy products, and other items have a finite shelf life. They deteriorate over time. Items or things that deteriorate are referred to as degrading items. The inventory system is plagued by issues caused by the deterioration of items or products. The change in demand rate could also be linear, i.e., demand might increase or decrease linearly with time. We employ a linear polynomial as a demand function for linear demand. It should occasionally be a significant change in demand, i.e., demand is rapidly increasing with relevance time. A biquadratic polynomial demand function can be utilized to achieve this increment. Biquadratic demand can help you reduce inventory costs and grow your business. In 1963, Gare and Schrader noted that some products deteriorate by a negative exponential function concerning time. This observation gives the differential equation of inventory products with deterioration. An inventory mathematical model for degrading products with exponentially deteriorating demand was proposed by Liangyu Yang, Kunchan Wu, and Meichuan Chen, 2005. Alfairs, 2007, looked at the inventory policy for an item with a demand rate dependent on the stock level and a storage time dependent on the holding cost. In 2008, Ajun Deroy created a mathematical model for decaying items in which demand depends on price. He'd also added a time-based holding cost. The case in which degrading rate follows Weibull distributions, C.K. Tripathi * and U. Mishra, 2010, devised a listing model. A list model for decaying products was presented by R. Amutha and Dry V. Chandrasekaran, 2012. Demand was supposed to be a straight line in this model. The cost of holding is calculated as a linear function of time. Dr. Ravish Kumar Yadav and Ms. Pratibha Yadav, 2013, demonstrate the production model with assumption of cubic demand rate. R. Venkateswarlu and R. Mohan, 2014, created a list model for deteriorating products constructed on the hypothesis that demand is a quadratic function of time. This concept was created to lower total inventory costs, TIC. Garima Sharma and Bonavias, 2018, suggested an inventory model for decaying products with a Weibull distribution. Demand is measured to be a 1-degree function of time, with shortages permitted and partially backlogged. Ganesh Kumar, Sunita, and Ramesh Inaniyan, 2020, proposed a listing model with a time-dependent demand rate employing various factors. It is supposed that the demand rate is a 3-degree polynomial of your time. The demand rate is treated as a cubic polynomial of time in this paper, and the deterioration rate fluctuates with time. The cost of the order is believed to be constant and does not fluctuate over time. This model's convexity is checked using a 3-dimensional graphical representation. To validate the model, an illustration is also created. The ideal solution has been subjected to a sensitivity analysis concerning essential factors, and the results are displayed. Conclusion. The sensitivity analysis found that in the case of cubic demand, a function of time, the model predicts that the rate of deterioration will alter over time. It can be shown that parameters A and B are directly proportional to Tc, whereas the parameters C is inversely proportional to Tc. It also demonstrates that this technique can be used to determine the total inventory cost. This also shows that total inventory cost minimizes in case of variable holding cost. Finally, a graphical depiction is used to verify the model. The obtained findings determine the model's stability. This model can be expanded or replaced with a different demand rate.